Hello students, in today's lesson we will be solving three problems from Physics GATE examination 2020. First let us do a simple problem. Which one of the following is the correct binary equivalent of the hexadecimal F6C? We all know the conversion between different number systems. How do we convert hexadecimal number to its equivalent binary number? Each of the hexadecimal digit is to be converted into its equivalent binary number in 4 digits. For example, hexadecimal number 0 is converted to its binary equivalent 0000. Hexadecimal digit 2 is converted into its binary equivalent of 0010 and so on. Similarly, the binary equivalent of F can be found out as 1111. It is very easy to remember because 1111 is the highest possible 4-digit binary number. The hexadecimal equivalent of six is 0110 and that of C is 1100. Hence, the binary equivalent of hexadecimal number F6C can be found out as 1111, 0110, 1100. And if we look at the options we have, option B is the correct answer. You can find that B is correct even without working out this much because only option B starts with 1111. Since F6C starts with F, the first number should be 1111. So it is very simple to identify by looking at the options at the first time itself. Now another problem from classical mechanics. The potential energy of a particle of mass m is given by U equal to a sin k square x minus pi by 2. The angular frequency of small oscillations of the particle about x equal to 0 is. What is the equation connecting potential energy and angular frequency? Maybe we do not know. Let us find out that first. I have found out here the equation connecting U and omega, potential energy and angular frequency in two different ways. Let us look at them. We all know the potential energy of a particle executing small oscillation is given by half kx square. Differentiating this equation U equal to half kx square 2 times, we get d square U by dx square equal to k. The differentiation is with respect to x. Now again we know omega square equal to k by m. This is a fundamental equation in small oscillation. Maybe you must be thorough with that. Omega equal to root of k by m is another way of representing this equation. Then comparing the second and third equations, we can easily find out that omega square equal to 1 by m d square U by dx square. So this is the equation connecting angular frequency and potential energy in a system of small oscillation, executing small oscillation. Then another way of finding out the same equation is, we know the equation connecting force and potential energy is F equal to minus du by dx. Also in the case of small oscillation, F equal to minus m omega square x. This is also a fundamental equation in small oscillation. Then equating these two equations, first and second equation, we get minus du by dx equal to minus m omega square x. Differentiating this equation once again and rearranging the term, we get 1 by m d square U by dx square equal to omega square. So we have got the equation connecting angular frequency and potential energy. All we need now is to apply this equation in the current scenario. Now our u of x is given as a sin k square x minus pi by 2. We are differentiating our u with respect to x 2 times to obtain d square U by dx square. Then we will multiply it by 1 by m to get omega square. The question asks to find omega at x equal to 0. So I will be substituting x equal to 0 in the equation of d square U by dx square. Therefore, my final substitution will be like this: d square omega square equal to 1 by m into minus a sine k square x will now become 0 because x is 0 minus pi by 2 k raised to 4. All the equations, all the terms are carrying over to the substitution, and the only modification we have made is that x is 0. Now we need to find the value of sine minus pi by 2. Sine minus x is minus sine x. So sine minus pi by 2 is minus sine pi by 2, which is minus 1. Therefore, simplifying the above substitution, we get omega square equal to k raised to 4 m, k raised to 4 a by m, from which omega can be calculated as k square into root of a by m. Therefore, option B is the right answer. Moving on to the next question. One thing I need to mention now is that this is a common kind of question often asked in entrance examinations relating potential energy with the angular frequency. Please be thorough with these kinds of questions. Now let us move on to the third question. Consider the circuit given in the figure. Let the forward voltage drop across each diode be 0.7 volt. The current I through the resistor is. The 10.1 voltage of input supply will be dropped across these three diodes and the resistor. So we need to find the voltage across the resistor. Let's look into that. Here we can see that the input voltage is 10.1 volt, of which 0.7 volt is dropped across these three diodes, which are all forward biased. The remaining voltage is 8 voltage, which will be obtained across the resistor. Therefore, the current through the resistor is V by R equal to 8 volt by 1 kilo ohm, which is 8 milliampere. So the final answer is 8. Hope you have understood all three problems. Thank you.